Any question is given like this, first statement. You have to consider the function as a raised to x. A is any number. That number you have to find. To find the value of this a, some expression will be given. Some values will be given in the question. Right? Second one. If question is given like this, f of x plus f of 2 minus x here equals to 1 is given. So in that case, you have to consider value of the function. That means expression of the function as a raised to x. Here, as you can see, there is no root here. So without root, you have to consider this here. Right? This you have to keep in mind. Okay, definitely we will solve some problem based on this one. Right? So again, for third one, if any expression is given f of x plus f of 1 upon x
These are kind of properties.
what?
These are these are properties also.
No, I did not get you. What? Yes, these are the properties, right?
I'm asking whether these. Huh.
These are the properties also. Based on these properties, see same type of expression, same type. See this same expression will be given in the question. This one. If you are finding same expression, then you can consider value of fx. Value of fx, either it will be 1 minus x raised to n or it will be 1 plus x raised to n, right? So either value of the function you can consider this one or this one. So any one of them between these two, right? You can consider the function. So which one we have to consider here? It will depend upon the question that I will discuss, right? No problem. Next, suppose now see next one, fourth one. If any expression is given like f of x plus y equals to f of x into f of y, or f of x minus y equals to f of x upon f of y. This will be the value of fx will be a raised to bx, right? A will be any constant, b also will be any constant with variable, right? So you have to consider this type of function, right? For this one, you know log property. Log property is that if argument is given in product form like log of xy, so that one you can write down log x plus log y. This is same. So in this case, you have to consider value of fx as k times log of a with x, log of x with base a. Here, depending upon some values will be given in the question, right? So by using that values which will be given in the question, we will find the value of k, and we will get some value of k 1 2 3 4 5, any value. Similarly, we have to find the base of the same number. Means these some values will be given in the question. Using that values, we will find value of k and a. Then original function we will get this one. We will put value of k here, a here. Then that will be our original function, value of the function, right? Similarly, x plus y, this is equals to f of x plus f of y. So for that type of function, we have to consider f of x equals to kx, right? See, we don't memorize this one, but while if you are getting any question, it is giving like f of x plus f of y equals to some another function. So we will go through these properties. We will find which property is useful, which property is applicable for that question. So like this one is property, right? So you can memorize. Means by using this property, you can keep this property in your mind. This automatically this will get into your mind by using in the question. Same f of xy, it is written f of x into f of y. Then value of fx will be x raised to some constant, right? X square, x cube, any number, right? Here, this one. Now next one, property 8. if it is written f of xy equals to f of x also and f of y also, then value of function means function will be any constant function, right? A continuous function like f of x takes only, see, one more important property, this ninth one. If any question is given and the question it is saying that this function takes only rational values, either it takes irrational values, for that type of function, that function always will be, f of x will be a constant function, right? Similar like this a property, right? It will be always a constant function. So this 9 also, for question number 9 also, I'll be discussing a question for property number 9 also, right? Now next one, property, see these properties I will be discussing in the few next chapters also. Like there is a chapter called complex number. There also I will discuss these properties, some of these properties. So this one. So if f of x plus y plus f of x minus y, it is equals to 2 times f of x into f of y. Then function will be either f of x equals to cos x, or either it will be equal to some constant raised to x plus some constant raised to minus x divided by 2, right? K for real number. This one. These properties are very, very important. Okay. So by using these properties, right, you can recall this one. Just write down all these properties. Okay, then I will discuss some questions also based on the same type of properties. Note it down this one. Note down these properties. And keep your cameras turned on, right?
Okay, sir.
Your cameras are turned off, right? That means you are not in the class, right? Maybe you will be doing some another work. Now open your module and page number 82.
Yeah, 8 minutes, sir.
Page number 82. Lakshya, do you have modules? Yes. So
Yes,
it's
sir.
page number 82, question number 7.
I don't have, sir.
Lakshya, send the photo in the group.
Sure, sir. Class activity level 1, sir.
Question number 7. Level 1. Yes, level 1,
Oh.
question number 7. So the question is f of x equals to 9 raised to x, 9 raised to x plus 3, right? This is given in the question. And then we have to find the value of f of it is f of 1 upon 1 by 1996 plus value of f of 2 upon 1996 plus dot 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 f of 1 1995 by 1996, right? Now just check all these properties. Which property is applicable in this question?
F of x plus f of y and so on
Just see property number 1.
up to f of some
It
n
is
number.
directly
So
applicable here. Property number 1. A raised to x upon a raised to
how?
x plus root of a. This thing is
Okay.
given,
Okay.
right?
I didn't
This
see
thing
that.
is given. The same property is applicable. That means if this function is given as f of x equals to a raised to x, a raised to x divided by a raised to x plus root of a. The same thing is given, it is here. Now, if this one is given, that means f of x plus f of x minus 1, this should be 1, right? See this one, 1 minus x, right? 1 minus x, this should be equals to 1, right? So now check, this is f of x and this number is 1 minus x, I think so. So 1 minus, just if I write down 1996 minus 1 divided by 1996. So this we can write down 1 minus 1 upon 1996, right? So this function can be written in this format. So f of 1 1996 plus f of this we can write down 1 upon 1996. This function is this one and this function is this one, right? Any doubt?
Yes, sir.
So addition of these two functions.
But y is 1 minus x.
If you solve this, how much you will get?
But y is equal to 1 by 190, 1996.
What's your doubt? Why this property we are applying here?
Why is it? No, sir, I can understand that. But how are we equating that? Like, how is f of x equals to f of 1 by 100 and, 1099, 996?
Now just see here. See, if any function is given in the form of a raised to x and a raised to x plus root a, right? This is value of f of x. Now what is the value of 1 minus x? F of 1 minus, what is the value of this type of function? So for 1 minus x, in place of x, we have to put 1 minus x. So a raised to 1 minus x divided by a raised to 1 minus x plus root a. We are now, I am proving here the property number 1. Now just add these two numbers. Fx I have just taken like this. And f of 1 minus x, we are just putting a 1 minus x in place of x, right? So here, so if I add these two number, f of x plus f of 1 minus x. So this is a raised to x divided by a raised to x plus root a, plus this one is a raised to 1 minus x divided by this is a raised to 1 minus x plus root a, right? Up to here, any doubt? Now just take some manipulations. A raised to x, this is also a raised to x plus root a plus this you can write down a into a raised to minus x divided by a into a raised to minus x plus root a, right? So here a raised to x divided by a raised to x plus root a plus this you can write down a divided by a raised to x divided by a upon a raised to x plus root a, right? So this is a raised to
Yes, sir.
x, a raised to x plus root a plus this here after taking LCM, you can write down 1 upon a raised to x divided by a plus a raised to x root a, right? Divided by a raised to x. So this a raised to power x, a raised to power x cancel out. So we are left with a raised to x divided by a raised to x plus root a, right? So this we have again a upon this is a plus a raised to x root a. Now rationalize these two numbers, right? After rationalizing, this numerator denominator will become same, right? Just you can rationalize it also. You will get something same numbers also, same number also. This will become 1. So every day, for example, suppose you can consider this a small function. This is going to be lengthy one. So like 9 raised to x upon 9 raised to x plus root 9, that is 3. Okay. For this one, you can find out value of 1 minus x. So f of x or f of 1 minus x, addition of these two numbers, this will become 1. Right. So that's why if any function is given in this form, then addition of f of x plus f of 1 minus x, this will be equals to 1. Right. So the same property we have to use here. This one. So this is because this is given. So f of x, this number, and this number is working as, this function is working as f of 1 minus x. Right? This 1995 divided by 1996, you can write down like this. So here f of 1 upon 1996 plus f of 2 upon 1996 plus like this. Last number is f of 1995 divided by 1996. So here if any expression, like because function is given, so f of x plus f of 1 minus x, this will be equals to 1. So we have to identify which function is working as f of x, which function is working as f of 1 minus x, right? So if we write down this number, this, suppose if I consider this value as x.
This property is holding for all the functions.
Yes, this property is valid only if function is looking like this. If see the property 1, if any function, any f of x is looking like this, a is some number raised to x, again same number raised to x plus root a. If any function is looking like this one, then f of x plus f of 1 minus x will be always 1. Right? So as you can see, question number 7 from page number 82. This is the question. In the question it is given, f of x equals to 9 raised to x divided by 9 raised to x plus root 9, that is 3. This is given. And see, I think Lakshita has sent you a photo on WhatsApp group, right? Just check that photo and see the question number
Yes, sir.
7. So question number 7 is find the value of this type of expression, f of 1 upon 1996, like this one. So in this, whatever is given, or if any expression is following, like f of x plus f of 1 minus x, so value of that addition will be 1. We need to check which one is here f of x, which one is f of 1 minus x. So as you will see, if I consider f of x as 1 upon 1 1996, so what will be the value of 1 upon 1 1996? This is 1 minus x, right? So if I consider this,
1995.
this will be f of
The
1995
last
divided by 1996. So sum of these two functions will be equals to 1. That means in this expression, sum of these two number will become 1. These two functions will become 1. Right? Any doubt?
Yes, sir.
Now, so here sum of these two functions, this will become 1. Now next one. Next one is f of 2 upon 1996. This one. If I take here 1 minus 2 by 1996. Right? So what is the value of this expression? F of 1996 minus 2. How much you will get? 1994 divided by 1996. So is this value present in our expression in the question?
Yes.
If I consider this expression as f of x, right? So what will be the value of f of 1 minus x? That will be before this expression, you will get f of 1994 divided by 1996. So sum of this function and this function, again this will become 1. Because this is working as x and this is working as 1 minus x. Right? Now screen.
Now finally see your
Yes,
screen.
sir. Now it is visible, sir.
Now, so here this second function from starting and second function from last one. Right? Sum of these two functions, again this will become 1. Right? So similarly, how many functions
We
are
have
there?
many functions like that, na?
Yes, so
Like there will be around
from
like
1 to 1995. So total 1995 functions are there. For this one, we have to find the sum. Right? So as you can see from 19, so here 1 to 1995 functions are given here. So like 1 and 1995, sum of these two functions, this will become 1. Right? And second to last second also this will become 1. Right? So middle one will be left only here. So that is